Okay, so we are adding and subtracting rational expressions here. Remember, guys, rational expressions is just fancy math language for a fraction. So let's recap. How do you do this? That's it, right? Right. If the denominators are the same, fellas, you just add the numerators and you leave the denominator the same.
Wait, does this mean I have to make all the denominators the same?
But it's not as hard as you think. So, if I have common denominators, I just add across the numerators, okay? Right?
Yeah.
So, same thing, even if the denominators are a little bit weirder. So, say I had, I don't know, 2 over x minus 4 plus 7 over x minus 4. Well, what do you think that gets you?
9 over x minus 4.
It's the same thing. It doesn't matter. 9 over x minus 4. That's it. Okay? So the rules are the same. As long as I have common denominators, I just add along the top. Okay? Let me try and trick you now with a subtraction problem. Let's say I had, I don't know, 15 over x plus 1, and I wanted to subtract, I don't know, x plus 6 over x plus 1. What do you think that's going to get you?
X plus 9 over x minus 1.
X minus 9.
Yeah, that's, no, x plus 9. Final answer. Over x plus 1.
I like it. The denominator is going to stay the same, of course, right? Just like it did up here. Nothing changes. So my denominator is still x plus 1. You do have to be careful here because if you were thinking it's like negative x plus 21 or 21 minus x, you're doing it incorrectly. If I'm subtracting this whole second fraction, that means I'm subtracting both of these, the x and the 6, right? That is one of the most common mistakes, is that kids will only subtract that first number, not the second. You have to subtract the whole thing because I'm subtracting the whole fraction. So it's really 15 minus x minus 6. So those of you, oh wait, I don't like it. You said no.
Wait, wouldn't it be negative?
It'd be negative x plus 9,
Oh,
right? Because we have to subtract the x as well. So just be careful of that. If it's subtraction, you have to subtract all the terms. Okay? Not just the first one, all of them. Okay? Let's try one more like that, and then we'll change things up a bit. Say I had x plus 4 over, I don't know, x squared minus 6 minus x minus 5 over x squared minus 6. All right, try that. Oh, sorry.
Maybe when it gets cold.
9 over x squared minus 6.
Negative
There's-
x minus 1 over x squared minus 6.
Negative x plus 9 over x squared minus 6.
X minus x is 0.
There's some right answers out there
4 minus
Wait, was mine
over
right?
and a whole bunch of wrong ones.
Negative-
Okay.
Wait, negative x minus 1 over x squared minus 6.
9 over x
Or
squared.
no, there are no x's.
So, yeah. All right, guys. All right. Come back to me here. So the denominator, we can all agree, is x squared minus 6, right?
Yeah.
Okay, good. The numerator, remember what you're doing. So sometimes I like to rewrite it. I'm doing x plus 4 minus x plus 5, right? Because I need to subtract both of those. So when I combine like terms here, x minus x, well, they're gone. And then I have 4 plus 5. I just get a 9.
What did I tell you?
That makes it.
Okay, so just be mindful of that. So if I have common denominators, okay, life is pretty easy. I just add or subtract as I'm told to do. With addition, it's super easy because you don't have to worry about this distributing thing. But when it's subtraction, just be mindful. You have to minus everything. All right, well, of course, denominators will not always be the same. So if you happen to have this packet that I gave you yesterday that had the number 15 on the top, or 2 days, I don't remember when I gave it to you. At some point. If you don't have it, it's not the biggest deal, but I'm just going to work through the first 6 on page number 16. So let's take a look at this first one. I do not have common denominators. Actually, before I do that, let me just rewind. Say I wanted to add these two together. If they don't have common denominators, actually, hold on. Let me change it. Sorry. Just kidding. Okay, say I want to add these two together. I don't have common denominators, right? So, what do I do? How?
Multiply the whole thing by, well, like, it's gonna be 1, but it's 2 over 2.
Yes, I multiply this guy by 2 over 2, which is really just 1. So I'm not changing the value of 1/4. I'm just turning it 4 quarters into a dollar or whatever, so I can actually use it. So now I have 3/8 plus 2/8, which gets me 5/8, and then I'm done, right? So remember that? Remember when you had to, okay. So then what happens if I have one like this? Now I want to do the one that I was originally going to do. 2/5 plus 3/8. I can't just multiply 5 by something to turn into an 8. So what do I do? Yeah.
You want to get a common denominator, so you multiply the first fraction by 8 over 8, and the second one by 9 over 5.
Yeah, in this case, the least common denominator happens to be 40, right? So I'm going to multiply you by 8 over 8 and you by 5 over 5. So sometimes you have to multiply both fractions by something, and that's okay. And now I get, what's that, 31 over 40? And there we go. All right? Sometime. Yeah. Yeah, they're already on Google Classroom. And by the way, when I made that joke earlier, like, oh, if only your Algebra 2 teacher had posted those videos. I'm your Algebra 2 teacher. He was like, well, he started talking about some dude. I'm like, what? Anyway, weren't you? Oh, yeah. But I said Algebra 2 teacher. If only your Algebra 2 teacher had posted videos on how to factor that you could go back to and watch at your leisure. Anywho, where the heck am I? Oh, yeah, we were going to do these problems on here. All right, so I'm looking at this one. And I want to get common denominators. I can turn a 4 into an 8. That's easy enough. But that's not all I need, right? Yeah, so I'm going to multiply this side by what? 2x over 2x. So now I'll have 3 over 8x minus 2x over 8x. And now I can actually do it.
So it would be 2x minus, or no, it would be 3 minus 2x,
Mm-hmm.
and then over 0.
Mm.
8x minus 8x.
Look here. Look when you subtracted these two.
Oh,
Oh,
it's just
right. The common denominator stays the same.
touch it.
That's right. You should be checking if this final answer can be simplified. In this case, it can't. But if this had happened to be a 4, right, I could have reduced all 3 of them with each other. So always, I mean, it goes without saying, but your answer should always be fully reduced. So there's my answer on that one. Okay, what do I have to do in this third one? Well, what will my common denominator be? 12x. So this guy needs an x. So I'll multiply by x over x. And this guy needs 4. So now I'll have 7x over 12x minus 16x over 12x. Oh, whoops, I forgot the x there.
In the end, will you be able to cancel the x's? Or no?
Yeah. So, I have common denominators. I can do the subtraction. What is 7x minus 16x?
Not negative 9x.
And you've got an x over 12x, which is 3, 4.
Right, so my x's cancel, and then I can reduce 9 over 12, negative 3/4 is my final answer. Oops, sorry. Okay, now 5 is a little bit different. Oh dear. Well,
Well, you're supposed to go first about that, can't you?
yeah, so basically, if you have any denominators, I'm only concerned about denominators here. If there's any denominators that can be factored, you should factor them. So, nothing to do here, but here I can take out a 4 and get x minus 7. Now it's a lot easier to see, oh, okay, they both already have x minus 7. It's just that this guy needs to be multiplied by 4. Do you see that? So if you have a denominator that can be factored, factor it. And then it's so easy to see what pieces you're missing and what you need. So let's multiply this one by 4 over 4. And we'll get 20x over 4 times x minus 7 plus 2x over 4 times x minus 7. So altogether, I'm going to get
22.
Can you reduce that answer at all?
Take out a 2.
So you can't distribute the 4 back into the.
You can, but you don't have to, so don't bother. I wouldn't, right? Why do more work than you have to do? But is that a final answer?
No.
You can reduce the 22 and the 4.
11.
11 over 2. Now I'm done. So my final answer, 11x over 2 times x minus 7. Is it wrong if you distribute the 2 back in? No, but don't bother doing it. You don't need to. So why open yourself up to making a dumb mistake on more work that you didn't have to do? Just leave it. So let's just try, let's try 6 before I give you some to try on your own. All right, so 6, a subtraction problem. I do have something to factor in the denominator, so let's do that. That one's going to stay, but factors of 24 that add to be 11, plus 3 and plus 8. You agree? So now I can see that the first fraction needs,
Y plus 3.
yeah, y plus 3 on top and bottom. So y plus 3 over y plus 3. So now, be careful, right? This numerator is now 6y plus 18. So I'm really doing, I'm going to write out more steps than you probably will, but it never hurts to write out extra steps. Just go one thing at a time. So there's my first fraction, right? 6y plus 18 over the y plus 3, y plus 8, minus 3y over that same y plus 3, y plus 8. So I have common denominators. All I have to do is the subtraction. So my new numerator is going to be 3y plus 18, and it's all over that common denominator, y plus 3, y plus 8. Am I done?
Nope.
Maybe, maybe not, because I can factor a 3 out of the numerator. If I factor out a 3, what's left behind? Y plus 6. Now that doesn't cancel with anything on the bottom, so I actually don't have to do it. But you don't know if it's going to cancel until you at least check real quick in your head, right? If I pull out a 3, I can't cancel a 3 with anything down there, and I don't have a y plus 6 down here to cancel it with. So I am done. I don't care if you leave the numerator as this or if you write it as 3 times y plus 6, because they're the same thing. It doesn't matter. But if there is something that will cancel in the denominator, you have to do it. So, I don't know. It's never a bad idea. Do you ever have to multiply all this back together? No, you don't. You do have to multiply out, like if I have to, you know, here I had to multiply these numerators together because I have like terms to combine. So I have to do the multiplication out here. But then when I have my final answer, you can just leave it. Okay? So you guys try number 4. If you don't have it on your sheet, there it is. I'm going to let you try it without me doing all the work for you. I always say that, and then I feel like I do it anyway. I gotta learn to step away. Oh. Hold on to it. Even if you tell me, I don't know if you're right, because I don't know the answer. Maybe I'll do the answer in secret. Ugh. The lead broke again. Wow. Okay, did everybody get an answer? Did everybody get this? At some point?
Point.
No. I got everything but the 5. Of like 5y plus 15, I got everything but the 5. I got 7.
You got a 7.
Yeah.
How?
Oh, I see how. Because I saw the 5, so instead of writing 3y, I wrote 5.
Oh, yeah. So hopefully you got this at some point, but hopefully this isn't your final answer. Because this can be simplified. In the numerator, I could take out a 5, can't I? And then you see that that does cancel with something downstairs. So I have to do it. Okay? So, Maddie, what was your final answer?
5 is y plus 5.
I agree. 5 over y plus 5.
Miss Savia,
Yeah.
in the question, it says 4, no, it says y squared plus 8x.
Yeah.
Is this supposed to be x or y?
Oh, I'm sure it's supposed to be a y. Good. Even after you said it, I'm like, well, yeah, so.
Yeah, Emily told me that's what I said.
Yeah, they should both be y's.
Yeah, they're all, it's all like, it's like that in number 6.
Oh. How funny. Like, I don't even pick up on it. I just assume. Yeah. They should all be the same variable.
I was like, okay.
Yeah, I'm sure that was just a typo. Okay, so what do we think? We can add and subtract? Yep. Sure. So what I would like you to try, well, actually, I want to do at least one together on this next page. Yeah. I guess. Super fast.
She just said no.
Whoever watches these videos are probably like, she has no kids left in the class. They all just leave.
Oh, no.
Okay. I don't have the time. I just leave it, let it roll. For the one person in the internet world that's ever gonna listen.
Wait, you don't edit your video?
No, I don't have time.
It adds comedy.
So they
Yeah.
all
It's gonna what's make your
So they're gonna hear all this?
Who's watching?
everyone.
I wish. Then I'd be a bajillionaire.
Views on some of them.
I do have. There's one video that's. I think I'm almost up to 1,000 views.
Yeah.
I know.
Were you sitting there like refreshing it every second?
No. I don't even remember how I found out. I don't know.
You gotta look
I
at
bet it was like one
After this,
person
yeah.
just hitting the
Okay, well,
refresh
look.
on the tab.
Okay. So, you have your puzzle packet that I gave you yesterday?
Yeah.
Let's look at the Helicopter puzzle. Remember my son says helicopter funny? Helicopter. I'll find a video where he's saying it. It's so cute. Anyway, so we're on this. Take your pick. Which one should we do together?
6.
6. Okay. These are all addition, so we don't have to worry about the subtraction part with these. So 6. Oh, I see something in my denominator to factor, so I should start there. A plus 7 and a minus 4. We agree? So then this side needs the m minus 4. And then we don't have a ton of room, but we will find a way to make it work. Okay, So now I have the common denominator, so I'll be doing 11m plus, don't forget to distribute here, m squared minus 4m, all over m plus 7, m minus 4. Oops. So, are you guys in agreement with me so far?
Yes.
So, I got common denominators and I added them together. I do have like terms up here, so let me join them together. So I'll have m squared plus 7m all over m plus 7, m minus 4. Am I done? Oops. Am I done? Is that a good final answer? Yep. You got it. Take an m out of the top, and isn't that going to leave me with an m plus 7 to cancel with the one on the bottom? So m plus 7s are gone. Looks like my final answer is going to be m over m minus 4. And hopefully that's a choice. Oh, it is! BIR. So what are you supposed to do? In the letters, yeah, in the 3 boxes that say 5, you put BIR, I guess. Okay, we are also going to do the other side. Why isn't a snowman very smart? I don't know. I've never done this one, so I don't know the answer. Which one of these do you want to do together? Pick any one you like. 10? All right.
Wait, can you go back to the other class? I think I did something wrong. How'd you get 7n at the top? If you're multiplying by 4.
You're multiplying by m minus 4.
Yeah, but you still get a 7.
I do once I do 11 and a negative 4.
Oh.
Yeah. Combine those like terms and you should get it. Okay, so the selection was number 10 on the snowman slide. So 10, all right, d squared minus 11. Didn't you just go to the bathroom? So why wouldn't you have done both of those at the same time? Whatever, it doesn't matter. Go ahead.
It looks trickier.
Instead of 10?
Yeah.
Or do you want to do both?
Yeah.
All right, we'll do both. So d squared minus 11 over d squared minus 7d plus 12 minus d plus 1, d minus 4. Okay, there's something to factor, so let me start there. D minus 3, D minus 4. Oh, sorry. I'll slow down.
Wait, what do you do on? I'm still on the last.
I'm on 10 on the snowman puzzle. So all I've done so far is factor the first denominator. And now I can see that the second fraction needs,
D minus 3.
yes. So I'll multiply by d minus 3 over d minus 3. Now, ladies and gentlemen, aren't you multiplying a binomial times a binomial here in this numerator right here? You, here, please take my advice. Foil these together first, and then I'm going to worry about the subtraction. Okay? Foil it together, and then I'll minus everybody afterwards. Okay? It's too much to try and do everything at once. So just foil these two numerators together. That's d squared minus 3 plus 1 is a minus 2d minus 3. So now, when I go to actually subtract these two fractions, they will have the common denominators, d minus 3, d minus 4. And then my numerator is going to be d squared minus 11, and now it's minus each of these things. So I'll have a minus d squared plus 2d plus 3. See how that works? Yeah. So FOIL, get your answer, and then you just know to subtract each one of these. And now I can just combine like terms in my numerator. So it looks like the d squareds will go away. And I'll have 2d minus 8. Right, now I see I can take out a 2. So now, so with subtraction, just be careful, you have to subtract all those pieces. Oh, is this even a choice? Oh, good, letter S. And I said we could do 9 together as well. Why don't you try 9 without me guiding you through it, and then we'll talk about it. So 9 on the snowman page.
Okay.
Oh, never mind.
9 on the snowman page.
Mm-hmm.
It's easier than I thought it was. I got scared by the d squared minus 2.
Oh. Well, there's still a lot of pieces in it, so it's a good one to try together. And we'll see who listened to me and who didn't. Bless you.
Bless you.
So, you'll know if you got the right answer, if it's at the bottom, of course, but let's just briefly talk about this. You should have factored the first denominator, take out a d, so the common denominator will be d times d minus 2. So your second denominator needs the d minus 2. So you multiply top and bottom by d minus 2. You have to FOIL again, d minus 4 times d minus 2. FOIL that together, and you get this. But then, when you actually do the subtraction, right, you'll have this first numerator, d squared plus 3, and then you need to subtract each of those 3 terms. So that's what I put down here. There's my first numerator minus each of those 3 terms in the second. All over that common denominator, combine your like terms, and you should end up here. And since nothing cancels, I'm done. All right, what do you think? We're okay? Yeah? All right. So what I would like to do is I would like to give you until quarter after to get as far as you can on both of these, on the helicopter and on the back. Huh?
I do 8.
Actually, it's not a bad one to do together either. So let's do that real fast. Yes. So here, there's nothing to factor in either denominator, and they're not the same, and it's not easy for me to turn one into the other. So just like when my denominators were 5 and 8, right? Didn't I just multiply them by each other? So that's basically what I'm going to have to do here. So I'm going to have to multiply this one by d plus 5 over d plus 5. And this one by 4d minus 1 over 4d minus 1. Okay? So looks like I'm going to have to FOIL here. This one I just have to multiply by 7, so that one's not so bad. But let's go ahead and give this one a shot and see if we all end up in the same place.
I know the answer.
How'd you do? Did you get what I got? Well, you'll know if you got it, what's on paper. So just make sure you foiled the first two. And then you'll see, so when I distributed the 7, I just distributed the 7. I'll worry about the minus later. It's too much to try and put everything all together all at once. So just go one step at a time. So there's me distributing the 7. And then down here, I went ahead and minus both of those terms. Okay? So then I don't lose track of things. I'm not like, did I already do that? Did I not? It gets all confusing. Just do one step at a time. So there's that. Combine your like terms. There are no factors of 17 that have to be a negative 21, so I know that I'm done. All right? So I am going to stop you at quarter after. So get as far as you can on both sides. Whatever you don't finish is not going to be homework. I'm just going to have you finish it on Monday when I'm not here. So get as much done now as you can, so then you'll have less on Monday. Don't worry, I'll have more stuff for you Monday. I won't overburden you, though. Don't worry. It's okay.